Around 13.8 billion years ago, the universe was unimaginably hot and dense. We still don't know how it got that way or even if the universe had a true beginning. Some theories suggest that our universe came into existence approximately 30.75 billion years ago. Shortly after that, the first light began to spread, illuminating the early universe. During this phase, the universe expanded rapidly in an event known as cosmic inflation. While that rapid expansion slowed down, the universe's growth has continued and has actually been accelerating due to a mysterious force called dark energy. But this raises an intriguing question. What lies beyond our universe? Physicist Brian Cox believes the answer could be deeply unsettling. What exists beyond the edge of the observable universe? In this exploration, we'll look into 5 compelling theories that attempt to explain what might be out there. When we talk about the universe, we often mean the observable universe, the portion we can see from Earth. This is limited by the speed of light. Because light takes time to travel, we can only observe objects whose light has had enough time to reach us since the beginning of the universe, which was roughly 13.75 billion years ago. Due to the continuous expansion of the universe, light from distant objects has stretched and moved farther away. In fact, the most distant light we can currently detect comes from objects about 45 to 47 billion light-years away. That gives us an observable universe with a diameter of approximately 93 billion light-years. Everything we've seen, quarks, quasars, stars, galaxies, nebulae, black holes, exists within this boundary. However, outside of this bubble lies the unknown. Scientists believe the actual universe could be far larger than what we can see, possibly even infinite. In this vast unknown, we might find galaxies, stars, and even Earth-like planets. One hypothesis suggests that if you travel far enough, you could encounter regions almost identical to ours, even ones with versions of ourselves living slightly different lives. This idea leads us to the concept of Hubble volumes, regions similar to our observable universe but beyond our reach. If the universe is truly infinite, then Hubble volumes could repeat infinitely, each one slightly different from the next. In some of these, you might have made different choices, creating a multiverse-like scenario of alternate realities. Now, why can't we just travel there? According to Einstein's theory of relativity, no object can move faster than the speed of light. But space itself can expand faster than light, meaning galaxies are moving away from us at speeds that make them unreachable. Even with futuristic technologies like wormholes or warp drives, reaching beyond our observable limits might be physically impossible. In 2008, something strange caught the attention of astronomers. They noticed that galaxy clusters, massive structures made up of thousands of galaxies, were all moving in the same direction at incredibly high speeds, over 2 million miles per hour. This phenomenon was dubbed dark flow. These clusters are some of the largest objects in the universe. They emit intense X-rays which interact with the cosmic microwave background (CMB), the leftover radiation from the Big Bang. Scientists used this interaction, known as the Sunyaev-Zeldovich kinetic effect, to detect slight changes in temperature in the CMB, revealing the motion of these clusters. Leading this research was Alexander Kashlinsky from NASA's Goddard Space Flight Center. His team studied about 700 galaxy clusters located up to 6 billion light-years away. By comparing their motion to maps created by the WMAP, Wilkinson Microwave Anisotropy Probe, they found a surprising pattern. The galaxy clusters were all flowing in the same direction, as if being pulled by something outside our visible universe. This was a major challenge to current models of the universe, which predict a more random, evenly distributed motion on large scales. So what could be pulling on these galaxies? Some scientists suggest that massive structures exist outside our observable universe, exerting gravitational forces that influence the motion of these clusters. These could be colossal collections of mass and energy, or even completely unknown cosmic structures that lie beyond our reach. These structures could be so vast and distant that we'll never directly observe them. They may stretch across an infinite universe or connect with other universes. Some theorists propose that gravitational fault lines might bridge our universe to others, influencing motion across the cosmic divide. Of course, not everyone agrees. Some astronomers argue that dark flow might be a result of misinterpreted data or errors in measurement. There is still intense debate over whether this phenomenon is real or an observational illusion. Either way, it opens up some fascinating possibilities. One of the most exciting ideas is the multiverse theory, also known as infinity bubbles. This theory suggests that our universe may be just one of countless others. Each bubble in the multiverse could have its own laws of physics, constants, and even dimensions. The origins of this idea lie in inflationary theory, the concept that the early universe expanded rapidly after the Big Bang. Some physicists, including Alan Guth and Andre Linde, believe that this inflation didn't happen just once, but continues eternally in pockets of space. Each of these pockets could give rise to a new universe, a bubble in an endless sea of universes. These infinity bubbles may never collide or interact because the space between them is also expanding. Even if you could reach the edge of our universe, you'd find yourself in an ever-expanding space that pushes the next bubble further away faster than light can travel. Each bubble could be radically different from ours. Some might have stronger gravity. Others might have different chemical elements, or no stars at all. The possibilities are endless. But there's a catch. As amazing as the multiverse theory is, it's hard to prove. These other universes are so far away, and so separated by the laws of physics, that we might never be able to detect them. Observational limits mean we can't test this theory in the traditional scientific sense. Still, some scientists believe we might find indirect evidence. Tiny irregularities in the cosmic microwave background, or strange gravitational waves, could hint at the presence of other universes. For now, though, these are just clues, faint whispers of something far bigger than we can see. This hypothesis suggests that these outside gravitational forces, perhaps from structures outside of our current universe, are what caused the dark flow observed. Dark flow as a thought is one that suggests a much more intricate and interrelated universe than before imagined. It does this by proposing the existence of immense unseen structures that could extend infinitely, which have gravitational pulls strong enough to affect the motion of galaxy clusters over distances of billions of light years. These theoretical structures beyond our Hubble volume may differ incredibly in shape and composition. They may range from gigantic concentrations of matter and energy on scales beyond imagination to mysterious fault lines channeling gravitational forces from nearby or parallel universes. This theoretical model opens doors to considering the nature of cosmic connectivity and the possibility of overlap between our observable universe and universes beyond. Although its consequences are deep and wide-ranging, dark flow remains a controversial concept within the science community of astronomers. Critics pose that the seen phenomenon could actually be an artifact of systemic mistakes in observations and interpretations in observational methods or methodology instead of an actual sign of cosmic dynamic properties. In addition, dark flow supporters being influenced by immense external constructs is questioned in view of needed additional empirical evidences and updated theory models. The theory of infinity bubbles or multiverse theory is one of the most stimulating and controversial hypotheses in modern cosmology. It defies standard thinking of an isolated observable universe by suggesting that there are many coexisting universes, each with its own unique physical laws and constants. This investigation enters the world of multiverse theory, exploring its history, consequences, and current controversy within the fields of theoretical physics and cosmology. The foundation of multiverse theory is rooted in efforts to resolve basic questions regarding the structure and evolution of the universe after the Big Bang. Cosmological models explain that the universe experienced an inflationary rapid expansion during its early days, when it was exponentially growing in size in an incredibly short span of time. This inflationary phase, proposed by theorists such as Alan Guth and Andre Linde, laid the ground for the creation of large cosmic structures and the matter distribution seen today. Within the context of inflationary cosmology came the idea of eternal inflation, a theory proposing that inflationary mechanisms might take place on an ongoing basis in specific areas of space. As a result, such inflationary pockets might give rise to separate domains or bubbles in the fabric of spacetime, each containing its own universe with different physical properties. The phrase infinity bubbles captures the notion that in an infinite universe, there could be infinite regions, each a separate, self-contained universe, potentially existing. These bubbles, brought about by quantum fluctuations or spontaneous variations during inflation, are independent systems with their own laws of physics. The important point is that each universe in this multiverse scenario is consistent with the known laws of physics and the constants, like the speed of light and the gravitational constant. In this model, the enormity of spacetime provides room for the existence of an infinite number of universes, each in its own bubble of reality. Though infinite, the distance between bubbles increases with time as a result of continued cosmic expansion, making travel between them impossible. Even if it were possible to cross the edge of one bubble, the space in between would continue to expand at a rate greater than any possible speed. Multiverse theory proposes a universe in which the idea of infinity goes beyond human limits of understanding. It predicts that there is a universe beyond our observable one, and that this universe is a cosmic canvas of endless variety, with every bubble containing a distinct realization of physical laws and cosmic circumstances. This variety raises questions about universes entirely unlike our own, where the fabric of existence itself may unfold in radically alien patterns. In every bubble universe, theoretical physicists ponder the possibility of different types of matter, energy,